everyone. I'm Hend Faisal. I'm a malware researcher, specifically in artificial intelligence. And I'm working as an anti-malware software developer engineer here in Egypt. And today will be presenting my survey paper. Then let's start. Okay, our table of content, we start with the introductions, and we'll talk about the literature review, challenges, and conclusion, our next step. Let's start by the introduction. Then what is malware? Malware is a short of malicious software. The name of malware is any software that is designed to cause disruption to PC, to server, to mobiles, to whatever, any something that's connected to the internet could be targeted by malware. Daily, there are 450,000 malwares are discovered. I believe that in our second, we are talking one malware attacker is spreading a malware. Then that shows how malware is spreading fast and how hard it is, or the causes of it. Based on AV-Test, AV-Test is an antivirus test-rated institution. From 2013 to 2022, you can see the evolution of malware. Every year is more. There are more malware to be discovered than the year to be invented than the year before. Especially during the COVID-19, how people became remote. That makes some organizations became vulnerable to malware more because of the lack of experience in security, how to secure their mobile phones or PCs during the pandemic. Then traditionally, how antivirus solutions relied on to discover malware. Traditional antiviruses relied on signature-based, on heuristic-based method. Signature-based means that you find the file, this file have a hash, you discovered, you put this hash in your database, then anytime anyone open a file with this hash, it could be discovered as malware. Maybe some strings in the file. If you find these strings, you can detect this file as malware. Heuristic-based, explore the malware characteristics. All these techniques, traditional techniques, they are reactive. Then, as a malware researcher, it was mandatory to find a proactive way. Then it was the mainly why it became artificial intelligence became with malware detection. How any researcher focusing on it. Then simply, if you make a data set of malicious behavior and benign behavior, benign mean non-malicious, it's a traditional file with no malicious behavior in it, you can easily pick the malicious one. That's what the model do. That's what the artificial model do. That could be more that could be more in discovering unknown and zero-day malware that the basic or that traditional ways couldn't discover it easily. Then in my literature review, I chosen two different operating systems. Then why could I choose those two? Based on the market share. You can find that the market share, Android and Windows takes the most of our market share. Then those were the two I focus on. Especially Android is becoming trending nowadays in the malware detection field. Then that was an introduction, and my literature review, as I said, I focused on Android and Windows. I take each one of them and see what techniques people or other researchers use in malicious, in machine learning and deep learning. Some people use NLP. That was interesting and new. I could find the latest, I found the latest data sets because it's one of the challenges, the limitations. What is the limitations of malware? What is the challenges that appear to the malware researchers, especially the two malware who research with machine learning models to be anything, everything is automated. That was a contextual map. Let's see it in depth. This is the pipeline that anyone who wants to detect a malware use. I'll pass through it. First, if you're finding a data set, to detect a malware, you need to find a large number of data set as malicious data set, the same as benign data set to differentiate between them. Then you do the analysis. Analysis may be static or dynamic or hybrid. Both of them. Static means that you analyze the file without opening it or without running it. Takes strings, anything that could appear without running it. Dynamic means that you run the malware or this file in a safe environment like virtual machines, like sandboxes, and logs their behavior. Hybrid is common of them, both of them. Then after analysis, you extract some features and then doing a feature selection, then doing your classification. Your classification may be statistical, rule-based, and AI-based, and that's what we are focusing on. Then in my literature, I read 18 papers on computer and 16 papers on Android, and I discussed every paper on them on my paper. Let's discuss. I will discuss just two of them, of each of them, just because of time. Then this is the features that could be extracted. I believe that this is all the features that could be extracted from any computer executable, means API calls, PE header, DLLs, opcode strings, images. Images is trending nowadays. Combining image processing in malware detection with machine learning is so new and excited to be explored. Then this is what we can extract statically, then there are dynamic features as API call sequence, read file, then open file, then read file. The sequence could be an indicator to a malware. Registry, what file, if this file add to the registry, what it add, network, system calls, if it's down on kernel, memory usage. All this may be artifacts to that there is a malware or there's not, but that's what we use to differentiate. This is the first paper. I chosen two papers in each one, as I said, one for machine learning and one for deep learning. I picked this specifically because I found out that was the most cited and the best accuracy, I believe. This paper depends on machine learning. Machine learning is malware detection. It depends on dynamic features. That means that the author took the file, ran it in safe environment like this, ran it in the safe in sandbox with something called Cuckoo. Cuckoo is just a tool. He picked up benign samples and malicious samples. I think they were 14,000, 7,000 benign and 7,000 malicious. He ran it in the safe environment on Windows 10, and then he extracted features. What is the features he extracted? He extracted an API called sequence. Then he made an extraction and generation. Then now he detects malware based on machine learning. He used those 5 algorithms: SVM, support vector machine, decision tree, random forest, XGBoost, and Pacific aggressive. The one with the best accuracy was random forest with 99.8. This paper not only detects if the sample is malicious or benign, it's made something other than this. It determines the type of the malware. If it's Trojan, if it's ransomware, worm. I believe this paper was so good. This is the first one. Second one, this paper depends on deep learning model. It extracted This paper is a visualization-based method. That's what I was talking about. It's new that he determined that the file is malware or benign by image. He first took the binary file, scan each file. He converted into 1D vector from 0 to 255, 0 for black, 255 for white. Then these bytes are organized into 2D array visualized as grayscale. Then now he could have a dataset. Then he reshaped the images. Why did he reshape the images? Because CNN doesn't accept images with different resolution. Then he used CNN and dense model, and he predicted his prediction, or his accuracy was 98. Those was the best two, I believe, in my point of view. All of them have their own point of view, but I believe that those were the best of them. Second, Android. Windows behavior is, as Windows and Android are two different operating systems. Every one of them has its own featured extraction week. Then here are the features that could be extracted from the Android, the manifest file, the permissions. What is the permissions it take? It take camera permission, it take recording permission. All of this can be our artifacts, strings of codes. That's for static, dynamic, same as Windows API call sequence. Here can be the user interactions, what the user do, events, what are the events he do. Let's talk about the first paper. This paper was not only depending on scoring and grouping technique. Its accuracy not, you can see that it's not the best, 94, but this paper was with different technique. Most of papers I found was getting the API calls or API call sequence, but this has a different point of view that made the scoring, grouping techniques. Yeah, then he started to extract features, to extract API calls from malicious and benign samples, and then he started to study them as to see what is API call that is being found in both, or what is being found on malicious more than benign. Or he found that there are some API calls that are found in malicious samples only and never to be seen in benign. That was his grouping techniques, ambiguous, risky, and disruptive. That's what I said. Ambiguous, that common in both with the same sequence, disruptive, more malicious, more found in malicious, but not found in benign. That I believe they were only five, but that is so risky. And risky API for more malicious, but less in benign. This used the machine learning algorithms, random forest, J48, random tree, CNN, and naive based, and also the one with the best accuracy was random forest. I found that random forest was the one with the best accuracy in all. Then this is the last paper. It's an Android detection technique. It used both static and dynamic. That means it's hybrid. It used both separately. Dynamic, he found out that by using the dynamic features, it's only 97.8%, and by adding the two dynamic and static features, it became 99.6. What is the features he found? He dynamically he sees the API calls and the action events. That was the user interaction I said before. He started to do a pseudo random stream of events to check what is the behavior of the sample. All of this is dynamically, and he after he did that and found out that it was 97.8, then he started to add permissions. Permissions is a static feature, and it became 99.6 accuracy. That is their architecture. Okay, there are more and more papers. that could be found in the paper, but I think those 4 were the best for me. I found them interesting, and that's why I picked them up. Then what is the challenges that face malware researchers? The anti-analysis techniques. Now, if you want to dynamically analyze a sample, you analyze it in a sandbox or in a virtual machine. Malware authors or malware attackers found out that they could find a way to defeat to rain out from these techniques if it found that if it's ran on a virtual machine, its behavior change. Then as a malware author, I could, as a malware researcher, I couldn't find out that it is malware. Obfuscation and packing. Obfuscation make the samples couldn't be ever detected by only static. Evolution of malware. If we use the static-based method, there are something called genetic programming that could change a little bit in a file and then found out that the hashes changed or the control flow graph is changed. That's the evolution of malware. Dataset, I'm struggling in this phase right now in my new paper to find the dataset that is balanced to be as malware datasets not common to be found on the internet easily. That's main obstacle to any malware researcher. And basic AI obstacles like computational computing space, time, resources that it could be want. What is the conclusion? Or as a malware researcher, I am struggling in finding a new robust ways to detect malware, especially zero-day malware. As an antivirus, the anti-malware developer, it's hard, and it's the main thing I'm focusing on. That's why using machine learning or artificial intelligence in general to find a way to detect malware. And my paper highlights the limitations, the challenges, some datasets that are available on the internet to help any other colleague to start his new paper or his new research on malware. For me, my future work is I want to build an Android obfuscation detection system to detect if the sample is obfuscated or not before running on it and a malware detection system, and also to build an Android malware detection system. And thank you. That was all. I hope you find it useful. Thank you.